part 3 is very similar to part 2. The big difference being that now, instead of x equals to pi, we have x is equal to negative pi. So, let's look at what the graph would, ooh, that looked terrible. Let's look at what the graph would look like. So there's our axes, y and x. So what does the sine graph look like to the left of the x-axis? Well, if it was coming up there, comes down, back up, about here again. Sorry about the slightly messy nature. This line here is our line x equals to 0, where the sine graph comes back and hits again. This is our line x equals to negative pi, and this, of course, is our graph y equals to sine of x. And again, we're still bounded by the x-axis, this line here, so we're looking for this area in here. Now, the trick with area, because we're now under the x-axis, we can't just take the area itself, right? We can't just integrate it. We can't say that this area, let's call it A2, we can't say A2 equals to negative pi 0 sine of x dx. Why not? Because when you have an area beneath the x-axis in mathematics, that comes out as a negative area. So instead, we need to take the absolute value of sine of x in this case. So what do we get? But now this is very hard to integrate, sorry. Fortunately, we know that sine of x is non-positive, is negative or 0 for this region. So we know that this is the same thing as the negative integral of sine of x dx. And I can only say this, I can only bring this minus out, because I know it's always under. If it had gone up, I'd have needed to leave the absolute value signs in, and that would be a difficult integration, sorry. But now, this is something quite simple again, because it's just what we did in the previous couple of questions. It's the we use this antiderivative, negative cosine of x. Our bounds are now negative pi and 0, minus out the front, but then negative is going to cancel. So this is going to be the same thing as cosine of 0 minus cosine of negative pi. And this is 1, this is negative 1, minus negative 1 gives us 2. We're then asked to compare this with the answer in part B, and we can say the area found in C is the same as the area found for part B. And we're done.